Aston Martin F1 team may have finally found a way to stop the vibration problem that has been haunting their car. Over the opening races of the season, the team has been dealing with one of the most serious technical problems on the Formula One grid. Their car hasn't just been lacking performance. It has been producing unusually high levels of vibration from the new power unit developed together with Honda. And the problem hasn't been a simple one. Several technical reports suggest the vibration coming from the engine has even started affecting the hybrid battery system and other structural components inside the car. The impact has also been felt directly by the drivers. Fernando Alonso revealed that at one point he even lost sensation in his hands and feet during a race. In a sport where precision control is everything, that's a clear indication that something serious has been happening inside the car. What makes the situation even more complicated is that the vibration does not always appear when the engine is tested on its own. Instead, the phenomenon becomes significantly worse when the power unit is installed inside the AMR26 chassis. That realization pushed Aston Martin's engineers to investigate a critical possibility. The root of the issue might not be the engine alone, but the interaction between the power unit, the chassis structure, and the new hybrid systems. For weeks, the team's technical department has been working almost non-stop to understand the vibration pattern. And according to several recent signals from the paddock, they may now be seeing a direction toward a solution that hadn't previously been fully considered. This solution doesn't appear to involve a small component change. It could represent a much larger shift in how the car functions as a whole. The question now is this: has Aston Martin truly found the key to stopping their vibration crisis? And could the upgrade planned for Miami change the direction of their season? In this video, we're going to break down how the team may have identified the root of the issue, what kind of technical solution is beginning to emerge, and why some people in the paddock believe Aston Martin may finally have found a way out. So before we dive into the analysis, make sure you subscribe to the channel, because the story behind Aston Martin's solution might be far more interesting than it first appears. When the season began, the scale of the problem was not immediately obvious from the outside. From television coverage alone, Aston Martin simply looked slow and unreliable. But inside the garage, engineers were already seeing data that pointed to a far more complex issue. The first clear signs emerged during early testing runs, when the vibration signatures recorded through the car's sensors began to exceed the ranges typically expected from a modern Formula One power unit. Those signals were strong enough to trigger immediate investigation from both Aston Martin and Honda engineers. According to Koji Watanabe, the problem appeared only once the engine was operating as part of the complete car system, rather than as an isolated unit. During pre-season testing, we identified a significant vibration issue, Watanabe explained. On the dyno, the level of vibration was not particularly high. But once the power unit was installed in the actual car and run on track, very large vibrations appeared. That difference between dyno behavior and on-track behavior is crucial. A Formula One power unit does not operate in isolation. It forms part of the car's structural architecture, transferring loads through the gearbox casing and into the carbon fiber chassis. The entire structure acts as a connected mechanical system. If the frequencies generated by the engine match the natural frequency of the chassis or other components, resonance can occur. When resonance occurs, vibrations can amplify dramatically rather than dissipate. That is the scenario engineers believe Aston Martin encountered. Once the car was running at full speed on track, the combined interaction of the power unit, gearbox structure and chassis appears to have produced a resonance effect that had not been predicted during development. The first component to suffer from this behavior was the hybrid battery system. Vibrations began damaging the battery and its surrounding systems, forcing the team to take precautionary measures just to keep the car operational. Watanabe acknowledged that protecting the battery became the immediate priority. Our primary focus has been to reduce the aggressiveness of the vibrations toward the battery, he said. We have managed to lower that level significantly. It is still not perfect, but it is no longer damaging the battery. That intervention stabilized one aspect of the problem, but it did not eliminate the vibration entirely. Because even when the battery was protected, the vibration continued to travel through the car's structure and into the cockpit. That is where the issue began to affect the drivers. Alonso spoke openly about the severity of the vibrations after one of the early races, explaining that the sensations inside the cockpit were unlike anything he had previously experienced. "At one point, I lost all feeling in my hands and feet," he said. For a Formula One driver, that is an extraordinary statement. Drivers rely on minute levels of tactile feedback from the steering wheel, the pedals, and the seat of the car. Losing sensation in the limbs compromises the ability to control the car precisely. In a machine capable of exceeding 300 kilometers per hour, that is clearly not sustainable. The challenge for Aston Martin and Honda was that the problem could not be reproduced easily in controlled testing environments, because the vibration depended on the interaction between several systems operating together at speed. It only revealed itself fully during real track running. That meant the engineers had to rely heavily on telemetry analysis and simulation to trace the root cause. And because Formula One testing opportunities are extremely limited, progress had to be made under the pressure of an ongoing race season. Watanabe admitted that this lack of testing made the investigation significantly harder. "After the first tests, we had no opportunity to run further full on-track tests before the opening races," he said. That forced the engineering teams to examine every possible pathway through which vibration could be entering the chassis structure. One conclusion quickly became clear: this was not a problem Honda could solve alone. "The vibration issue is something we must address together with Aston Martin," Watanabe explained. "It is not purely a power unit matter." That collaboration has involved engineers studying how the power unit is mounted within the car and how structural loads travel through the engine casing and gearbox assembly. One of the figures closely involved in that process is Enrico Cardile, who has been working with Honda engineers to examine the structural integration of the power unit. In modern Formula One design, the power unit forms part of the load-bearing structure of the car. Any change in stiffness, mounting configuration, or load path can alter how vibrations propagate through the vehicle. That is why solving the issue is not simply a matter of replacing a component. It requires understanding the behavior of the entire mechanical system. The scale of Aston Martin's struggles has not gone unnoticed by observers across the paddock. Former Formula One driver and analyst Martin Brundle delivered a particularly blunt assessment when discussing the situation. "They've got to get the right people in at Honda and get the right direction," Brundle said. "At the moment, it's a horror show." He also highlighted the performance gap that had opened up. "They're sometimes 3 or 4 seconds per lap off the pace. That's like being in another category." That level of deficit illustrates how deeply the vibration problem has affected the entire car package. But other observers believe the situation may still be recoverable. Former driver turned analyst Jolyon Palmer emphasized that understanding the problem is the essential first step. Honda need to fully understand the issue before they can bring real performance solutions, Palmer said. Recent developments suggest that this understanding may finally be emerging. The early countermeasures focused on reducing the vibration's impact on the battery system, allowing the team to complete race distances more reliably. But the longer-term solution appears to involve revisiting the structural integration of the power unit within the car. Engineers have been studying how vibration frequencies travel through the engine mounting points, how the gearbox casing interacts with the chassis, and how the hybrid system contributes to the overall mechanical behavior of the car. By adjusting those relationships, it may be possible to break the resonance cycle that created the vibration problem in the first place. If that hypothesis proves correct, Aston Martin could finally stabilize the AMR26's behavior. And if the vibrations are reduced to acceptable levels, the car may begin to reveal performance that has so far remained hidden. That possibility is why attention is now turning to the upgrade package expected around the Miami race weekend. Within the paddock, there is cautious curiosity about whether those changes will confirm that Aston Martin has truly found the direction required to resolve the crisis. Because if the solution works, the narrative surrounding the team could change rapidly. Instead of a project defined by technical chaos, Aston Martin could suddenly appear as a team that solved one of the most complex integration problems of the season. But that outcome is not guaranteed. The physics behind resonance and structural vibration can be extremely stubborn. Sometimes small adjustments unlock the entire system. Other times the solution requires deeper structural redesign. which leaves Aston Martin at a critical point in its season. Have the engineers truly identified the path out of this vibration crisis, or are they still chasing symptoms of a deeper design issue within the car? And if the Miami update really does stabilize the AMR26, could Aston Martin suddenly re-enter the competitive picture far sooner than anyone expects? Let me know what you think. Do you believe Aston Martin and Honda have finally cracked the problem? Or is this vibration issue still a much bigger obstacle than the team is willing to admit? Write your thoughts in the comments below. I'm genuinely curious to hear whether you think this project is on the verge of recovery, or whether Aston Martin still faces a much longer road back to competitiveness.